warahmatullahi Assalamualaikum warahmatullahi wabarakatuh. Hello guys, in this moment we want to explain the material about parallel computer in the modern computing course. We are students of Gunadarma University, and here is our presentation. Definition of parallel. Parallel computing is a type of computing architecture in which several processors execute or process an application or computation simultaneously. Parallel computing helps in performing large computation by dividing the workload between more than one processor, all of which work to the computation at the same time. Most supercomputers employ parallel computing principles to operate. Parallel computing is also known as parallel processing. Parallelism concept. And one von Neumann architecture, named after the Hungarian mathematician or genius John von Neumann, who first authored the general requirement for an electronic computer in his 1945 papers. Also known as stored programmed computer, both program, instruction, and data are kept in electronic memory. Differs from early computers which were programmed through hardwiring. Since then, virtually all computers have followed this basic design, comprised of four main components: memory, B, control unit, C, arithmetic logic unit, and D, input or output. Read or write, random access memory is used to store both program instruction and data. Program instruction are coded data which tell the computer to do something. B, data is simple information to be used by the program. And control unit fetches instruction or data from memory, decodes the instruction and the sequentially coordinates operation to accomplish the programmed text. Arithmetic unit perform basic arithmetic operation. Input or output is the interface to the human operator. And 2. Flying classical taxonomy. There are different ways to classify parallel computer. One of the more widely used classification in use since 1966 is called Flynn's taxonomy. Flynn's taxonomy distinguishes multiprocessor computer architectures according to how they can be classified along the two independent dimensions of instruction stream and data streams. Each of these dimensions can have only one of two possible states, single or multiple. The matrix below defines the four possible classifications according to Flynn. And 1, SESD, and 2, SEMD, and 3, MISD, and 4, MIMD. And the next slide, 3. Limit and cost of parallel programming. For Adams' law. Adams' law states the potential program speedup is defined by the fraction of codes, or P, that can be parallelized. If none of the code can be parallelized, P equals 0 and the speedup equals 1 or not setup. If all of the code is parallelized, P equals 1 and the speedup is infinite or in the theory. And the next, if 50% of the code can be parallelized, maximum speedup equals 2, meaning the code will run twice as fast. Introduction: the number of processors performing the parallel fraction of work. It soon becomes obvious that there are limits to the scalability of parallelism. For the example, however, short-term problems demonstrate increased performance by increasing the problem size. Problems that increase the percentage of parallel time with their size are more scalable than problems with a fixed percentage of parallel time. And next, complexity. In general, parallel applications are much more complex than corresponding serial application, perhaps an order of magnitude. Not only do you have multiple instruction streams executing at the same time, but you have data following between them. The cost of complexity are measured in the program time in virtually every aspect of the software development cycle. E. Design. B. Coding. C. Debugging. D. Tuning. E. Maintenance. M. Adhering to good software development practice is essential when working with parallel applications, especially if somebody besides you will have to work with the software. And next, portability. And in the portability, thanks to the standardization in the several APIs such as MPI, PostEx and OpenMP, portability issues with parallel programs are not as serious as in years past. However, all of the usual portability issues associated with serial programs apply to parallel programs. For example, if you use vendor assignements to Fortran, C or C++, portability will be a problem. Even though standards exist for several APIs, implementation will differ in a number of details, sometimes to the point of requiring code modification in order to effect portability. Operating system can play a key role in code portability issues. Hardware architecture are characteristically highly variable and can affect portability. And next, resource requirement. In resource requirement, the primary intent for parallel programming is to decrease execution for clock time. However, in order to accomplish this, more CPU time is required. For example, a parallel code that runs in 1 hour on a processor actually uses 8 hours of CPU time. The amount of memory required can be greater to parallel codes than serial codes due to the need to replicate data and for overheads associated with parallel support libraries and subsystems. For short-running parallel programs, they can actually be a decrease in performance compared to a similarly serial implementation. The overhead costs associated with setting up the parallel environment, text creation, communication, and text examination can compress a significant portion of the total execution time for short runs. And next, scalability. In the scalability, two types of scaling based on time of two solutions: strong scaling and weak scaling. Once, strong scaling and the storage scaling, the total problem size stays fixed as more processors are added. And B, goal is to run the same problem size faster. C, perfect scaling means problem is solved in 1 or P time or compared to serial. 2. Weak scaling. E, the problem size per processor stays fixed as more processors are added. B, goal is to run larger problem in same amount of time. C, perfect scaling means problem PX run in same time as a single processor run. The ability of parallel programs performance to scale is a result of a number of integrated factors. Simply adding more processor is rarely the answer. The algorithm might have inherent limits to scalability. At some point, adding more resources causes performance to decrease. This is a common situation with many parallel applications. Hardware factors play a significant role in scalability. Example: E. Memory CPU bus bandwidth on an SMP machine. B. Communication network bandwidth. C. Amount of memory available on any given machine or set of machine. D. Processor clock speed. Power sports libraries and subsystem software can limit scalability independent of your application.
B. Distributed processing. Distributed processing is a setup with which multiple individual central processing units or CPU works on the same programs, function, or systems to provide more capability for a computer or other device. And C. Architectural parallel computing. Number 1. Parallel computer memory architecture and distributed memory. General characteristic: Alexa memory system, distributed memory system vary widely but share a common characteristic. Distributed memory system require a communication network to connect inter-processor memory, and you can see the picture this. Processors have their own local memory. Memory addresses in one processor do not map to another processor, so there is no concept of global address space across all processors. Because each processor has its own local memory, it operates independently. Change it makes to its local memory have to affect on the memory of the processors. Hence, the concept of the change coherency does not apply. When a processor needs access to data in another processor, it is usually the task of the programmer to explicitly define how and when data is communicated. Synchronization between tasks is likewise the programmer's responsibility. The network fabric used data transfer varies widely, though it can be as simple as Internet. Advantage: Memory is scalable with the number of processors. Increase the number of processors and the size of memory increase proportionally. Each processor can rapidly access its own memory without interference and without the overhead incurred with trying to maintain global cache coherency. Cost effectiveness: can use commodity of the shelf processors and networking. Disadvantage: the programmer is responsible for many of the details associated with data communication between processors. It may be difficult to map existing data structures based on global memory to this memory organization. Non-uniform memory existence: data residing on a remote node takes longer to access than not-local data.
C. Architectural parallel computing. Hybrid distributed shared memory. General characteristic: the largest and fastest computer in the world today employed both shared and distributed memory architecture. The shared memory component can be shared memory machine and or graphic processing unit or GPU. The distributed memory component is the networking of multiple shared memory or GPU machine, which know only about their own memory, not the memory on another machine. Therefore, network communication are required to move data from one machine to another. Current trends seem to indicate that this type of memory architecture will continue to prevail and increase at the high end of computing for the foreseeable future. Advantage and disadvantage. Whatever is common to both shared and distributed memory architecture. Increased scalability is an important advantage. Increased programmer complexity is an important disadvantage.
B. Introduction Thread Programming. A thread in computer programming is a related information about the use of a single program that can handle multiple users simultaneously. Thread. This allows the program to know how the user entered the program in turn, and the user will re-enter using a different user. Multiple threads can run simultaneously with other processes dividing resources into memory, while other processes do not share them. E. Introduction Message Passing and Open Message Passing. Message passing is a form of communication used in parallel computing, OOT, object-oriented programming, or object-based programming and inter-processes communications. F. Introduction CUDA GPU Programming. GPU is a special processor to speed up and change memory to speed up image processing. GPU itself is usually located in the computer graphic card or laptop CUDA. Computer Unified Device Architecture is a sham created by NVIDIA for NVIDIA as a GPU, graphic processing unit, capable of computing not only for graphic processing, but also for general purpose. So, with the QDA, we can take advantage of many processors from NVIDIA to perform the calculation process or even computing a lot.
Hello guys, thank you for watching our video. I am Muhammad Tanto.
And I'm Merdeka Putra.
And I'm Fari Fauzan. And I'm Eri Rivaldi. And don't forget to like and comment for this video. And thanks for watching. Goodbye.
Assalamualaikum warahmatullahi wabarakatuh.
See you later.
Udah.